Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 12 mathematics, and in this video we'll be having a look at differential calculus under the topic of the factor theorem. So the factor theorem is necessary for us to be able to factorize polynomials. And you might be asking yourself, but then we've been doing factorization in grade 10 and grade 11. What's the necessity of us having to discuss the factor theorem? Well, you would remember that in grade 10 and 11 your factorization involved a quadratic expression, and in some instances the linear expression where you need to take out a common factor. With the factor theorem, we'll be able to factorize cubic expressions. So for example, expressions that contain an x cubed. We can even be able to factorize expressions with x to the power 4, x to the power 5, higher exponents than just 2. Now in grade 12, the highest exponent that you'll be asked to factorize would be x to the power 3, a cubic expression, where you do not necessarily go higher than the exponent of 3 in grade 12. However, what we learn here in the factor theorem will help you to factorize expressions which have higher exponents than just 3. So, in this video, we'll look at what polynomials are, what their properties are, how to identify polynomials. We'll then do a quick revision on what factors are, or what we remember from the lower grades as to what are the properties of factors. Then we'll get into the main video for today, the main content for today, which will be on the factor theorem. So stick around until the end and then you'll get to understand how the factor theorem works. Without any further ado, let's get straight into it. So by definition, a polynomial is an expression that is one or more variables or constants that have different exponents and coefficients. One important thing to take note of is that the exponents must be natural numbers. Now, what are natural numbers? You would remember we said natural numbers are counting numbers. These are numbers that include 1, 2, 3, etc. Basically the numbers that you use when you count. Now take note that natural numbers do not include negative numbers. Natural numbers do not include 0. Natural numbers do not include decimals. So, if I have an expression that has x to the power 5 minus 6x to the power 4 plus 3x squared, for example, this is a valid polynomial because each of the coefficients that we have are natural numbers. But if I, for instance, have negative 3 over x squared, I can simplify this to be negative 3x to the power minus 2. Now, this is not a polynomial. And why is this? Because our exponent of x is not a natural number, it's an integer. So how do you identify whether an expression is a polynomial or not? You basically need to look at each of the exponents. If the exponents are natural numbers, the expression is a polynomial. If the expression does not have any natural numbers for the exponents, then you know that it's not a polynomial. For example, I could have 3x squared minus 6 square root of x. Now from a distance you might think, okay, this is a polynomial because we've got an exponent of 2 there. However, let's check something out. According to laws of exponents, you will see that this is 3x squared minus 6x to the power half. Now this half is not a natural number. Therefore, this does not count as a polynomial. I hope that this makes sense to you guys. So, the highest exponent of a polynomial is called the degree or the order of a polynomial. So for example, if I've got x to the power 3 minus 4x squared plus 12x, let's say minus 9. The highest exponent in this polynomial is this 3. So this type of polynomial is called a third degree or third order expression. A third degree or a third order polynomial. A polynomial with only one term is called a monomial. I'm sure you're familiar with this from earlier grades like grade 8 and 9. A polynomial with 2 expressions is called a binomial, and a polynomial with 3 expressions is called a trinomial. Now you've been working with three-term polynomials or trinomials in the previous grades, especially when it comes to the first question in your paper 1, where you're supposed to solve for x. In most cases, you'll be using a trinomial. Let's have a look at what factors are. We said by definition that a factor is a number that divides exactly into another number without leaving any remainder. In other words, the remainder after division is 0. So let's have an example here. We have a fraction a over b equals to c. By the way, we said that a is referred to as the dividend. We call this the dividend. B is called the divisor. C is called the quotient. So what is the quotient? Remember we said from previous grades, the quotient is the answer that you get after division. Right. Now, b can only be a factor of a if the remainder after dividing is 0. So in this instance, to determine whether a number is a factor of another number, we do the division, but we're not so much interested as to what the answer is. What we are more interested in is what the remainder is. If the remainder after division is 0, then the number is considered to be a factor. Please take note of that. Right, let's get into the factor theorem. Now, suppose we have a polynomial f of x, and we have an expression x plus k. Any random expression. What we need to take note of is this: x plus k is a linear expression. What do we mean by this? The highest exponent of x is 1, so this is a linear expression. If we have f of minus k being 0, then x plus k is a factor of f of x. In other words, what we're saying is, if we take x plus k and we equate it to 0, then we're going to get that x is equals to minus k. When we substitute this x equals to minus k back into the equation for f of x, and we get 0 as an answer, then we say that this x plus k is a factor of f, because the remainder after division is 0. In other words, we are saying that if we divide f of x with x plus k, we'll get some answer, some expression, but we're not interested in the expression. We're interested in the fact that the remainder after division is 0. We can use this theorem, or this law that we've just learned, to factorize polynomials of any degree. As I've mentioned to you at the beginning of the video, that we could use the factor theorem to even factorize polynomials which go as far as x to the power 12 or even higher than that. In grade 12, you're only required to know how to factorize third degree expressions, third degree polynomials. We'll only be factorizing the cubic polynomials, as I've mentioned at the beginning. But the factor theorem helps you to identify the factors of these cubic expressions. Okay, without any further ado, let's get into some practical application. So, the first question says we need to find factors of each of the following expressions. We need to find a factor, at least one factor. So the first question we have is f of x equals to x squared minus x minus 6. Let's go to the writing pad and let's actually have a look at this. So, we are given f of x, whoops, my pen is a bit thick there. We are given f of x is equals to x squared minus x minus 6. Now, if you can remember from grade 10 and 11, this is a trinomial. It's quite easy to factorize and get both of the factors. All we just do is we open two brackets, then we put the square root of x squared, which is x, into the first two brackets. Now we look at the last term, which is negative 6. Basically, we need to find factors of negative 6. I can see there's 1 in negative 6. There's 2 in negative 3. There's negative 2 in 3. Then there's negative 1 in 6. What I need to do is I need to add these factors, and I need to take the answer that will give me the coefficient of the middle term. Now, the coefficient of the middle term is minus 1. Let's see when we add what we get. 1 plus minus 6, this is going to give us minus 5. 2 plus minus 3, this is minus 1. Negative 2 plus 3 is positive 1. Negative 1 plus 6 is positive 5. So basically, we are going to make use of these factors, positive 2 and negative 3, because when I add them, I get the coefficient of the middle term, which is minus 1. So I'm just going to put positive 2 there, and I'm going to put negative 3 there. And there we are. We've actually found both factors for this expression. Wonderful. Life is great. Let's look at the next question. So, in the next question, we have a cubic polynomial. G of x equals to x cubed plus 3x squared minus 2x plus 4. So let's write this one down. So we have got, let's just scroll down for some room. We have got g of x is equals to x cubed. Let's see what we have here. Plus 3x squared minus 2x minus 4. Let's just make sure of that. Yes, there we are. So let's factorize this expression. Now, at first glance, it might seem like, okay, what do I need to do here? Because you might be thinking, well, you've seen something like this in lower grades. You've seen something like this in grade 10, where you can group the terms in the expression. So you could use grouping. However, grouping does not work in this instance because there's no common factor in the pairs of expressions, the pairs of terms. What we need to do is we need to look at factors of the last term. So we look at factors of minus 4. What are the factors of minus 4? We've got 1, we've got 2, and we've got 4. We've got negative 1, we've got negative 2, we've got negative 4. And so basically what we need to do is we need to substitute by trial and error all of these factors, or at least one of these factors, into the equation and see if we can get y is equals to 0 as an answer. So let's start with x is equals to 1. So if I take x is equals to 1, g of 1, this is just going to be 1 cubed plus 3 into 1 squared minus 2 into 1 minus 4. And if you type this into your calculator, you will actually get an answer of negative 2. Now, we don't want this negative 2. We want something that's going to give us an answer of 0. So x equals minus 1 is out. Let's try x equals to 2. So g of 2 is just going to be 2 cubed plus 3 into 2 squared minus 2 into 2 minus 4. If you substitute this into your calculator, you will get 12 as an answer. Once again, 12 is out. We don't want it, so we don't consider x is equals to 2. Let's actually take x is equals to minus 1. So g of minus 1 is equals to minus 1 cubed plus 3 into minus 1 squared minus 2 into minus 1 minus 4. If you type this into your calculator, you will actually get 0 as an answer, which is what we're looking for. Therefore, we have found our factor. We would say here x plus 1 is a factor. Now, why are we taking the plus 1? Just remember from one of the previous slides that we had something like x plus k is equals to 0. Then we transposed the k. We got x is equals to minus k. Then we substituted this into the equation. So basically, because we've got x equals to minus 1 as an expression, sorry, as a factor, in our expression, what we need to do is we need to change the sign. So from negative 1, we substitute and we get x plus 1. Awesome. I hope that this makes sense to you guys. Let's have a look at the next question. So, in the next question, we've got k of x equals to x cubed minus 4x squared plus x plus 6. Let's go ahead and write this on my writing pad. I'm going to do this on a new sheet of paper. So, the expression that we are given is k of x is equals to x cubed minus 4 x squared plus x plus 6. There we are. So now we need to find factors of this expression. Once again, we follow the same procedure as we did in the first one. We look at our constant, which is positive 6. We need to find factors of positive 6. We've got 1, 2, 3, and 6 itself. Then we also have negative 1, negative 2, negative 3, negative 6. That's a terrible negative 3. Once again, we need to substitute by trial and error numbers into the equation that's going to give us y is equals to 0. So let's start off by substituting x is equals to 1. So k of 1, this is going to be 1 cubed minus 4 into 1 squared plus 1 plus 6. If you type this into your calculator, you will actually get an answer of 4. So x is equals to 1, that's out. Let's see what happens when we substitute x is equals to 2. So k of 2, this is going to give me 2 to the power 3 minus 4 into 2 to the power 2 plus 2 plus 6. This is actually going to give us 0 as an answer. So we found our factor. Our factor in this case is going to be x plus 2. So we could say x plus 2 is a factor. Sorry, x minus 2. So x minus 2 is a factor of k. There we have it. Life is great. We found our first factor. Brilliant. Let's look at the next question. So in the next question, we've got p of x is equals to x cubed plus x squared minus 9x minus 9. So let's go back to the writing pad and let's have a look at how we would do this one. So our expression is p of x is equals to x cubed plus x squared minus 9x minus 9. Once again, we need to go ahead and find factors of our constant. we've got negative 9 as a constant. The factors of negative 9, we've got 1, we've got 3, and we've got 9. We've also got negative 1, negative 3, and negative 9. So, once again, let's go ahead and substitute values into our expression. Let's start with p is equals to x is equals to 1. So, p of 1, this is going to give you 1 cubed plus 1 squared minus 9 into 1 minus 9. If you type this into your calculator, you would get an answer of negative 16. Right. We are not getting 0 as an answer, so that means p is equals to 1 is out. Let's try another expression, or let's try another factor. And the next factor that we're going to consider here is, let's try let's try x is equals to negative 3, and let's see what happens. So, p of negative 3, this is going to give me negative 3 cubed plus negative 3 squared minus 9 into negative 3 minus 9. If I substitute this into my calculator, I would actually get 0 as an answer. And because I've gotten 0 as an answer, I can conclude to say that x plus 3 is a factor. Awesome. I hope that this makes sense to you guys and that you're understanding the content so far. So, let's look at our next question. So, in our next question, we've got h of x is equals to x cubed minus 4x squared minus 4x plus 16. Let's go to the writing pad and write this down. So, once again, let's scroll down for some room. We have got h of x is equals to x cubed minus 4x squared minus 4x plus 16. Right. Once again, let's go ahead and find factors of our last term. So, factors of 16. We have got 1, 2, 4, 8, as well as 16. We've got negative 1, negative 2, negative 4, negative 8, and negative 16. Once again, let's try and substitute factors into the equation so that we can see which one gives us 0. Let's start with x is equals to 1. So, h of 1, this is going to give us 1 cubed minus 4 into 1 squared minus 4 into 1 plus 16. If you type this into your calculator, you will get 9 as an answer. So, x is equals to 1, that's out. Let's substitute x is equals to 2. When we substitute x is equals to 2, we get h of 2 is equals to 2 cubed minus 4 into 2 squared minus 4 into 2 plus 16. When we do this, we actually get an answer of h being equals to 0. Therefore, we can conclude that x minus 2 is a factor of this expression. Brilliant. I hope that this made sense to you guys, and I hope that you understand the factor theorem now. If you don't understand exactly why we are doing this, please stick around and watch our next video, because in our next video, we'll actually have a look at how to take this single factor and then get all the other factors from the expression. In essence, how to factorize the entire cubic expression using synthetic division and long division. So please do stick around for the next videos, as we'll have a look at how to do synthetic division as well as long division in more detail. I hope you guys enjoyed this. Please give us a like, please give us a thumbs up, subscribe to the channel, and then click on the bell icon so that you will always receive an update every time when we upload a new video. Until then, enjoy the rest of the day. Have a blessed day. Ciao.